Welcome to class today. Let's talk about some topics here in the building blocks chapter. Obviously, we're in the ebook yet again. We're going to look at addition and subtraction topics and spend a little bit of time thinking about that. In particular, let's just go back to something we've discussed already. What is the process behind adding binary numbers? I wanted to point out a couple things. Here's, for example, an addition of the number 1011 plus 0101. Let's, as I said, you can see it here, but let's look at that in a little bit more detail. So putting these windows side by side, obviously the first thing we're going to do is add 1 plus 1. The answer is 10, right? So there's a 0 and we're going to carry a 1 right here. Notice what we've done in terms of how that addition happened. What we did is we added just two numbers. In particular, we're adding specifically these two numbers. What this means is we're looking at what's called a half adder. In other words, we're adding just two binary digits. I'm going to call those binary digits A and B. And they would produce two things, a carry out. You can see the carry out being carried to the next digit right here, and a sum, which I've put right there. So in this case, we added a 1 plus a 1. Our carry out was a 1, which again you see as a carry in to the next binary addition. And we have a sum of 0 right here. This is a simple two-input binary function. Of course, we can pull up the usual simulation of that function right here in our circuit simulator and see quite obviously that 0 plus 0 is 0. If you add 1 plus 1, that's when we get our carry out with a sum of 0. But if we're ever adding a 1 plus 0, obviously we're going to get a sum of 1 and a carry out of 0. So really, when we're adding 2 bits, we've got a half adder, and we're only producing two outputs, a carry out and a sum. Now let's spend a minute and talk about how not just to implement that if we were wiring up discrete logic chips, but we'd like to be able to implement that using Verilog, which allows us to design large and complex chips. So I'm going to go click on the main heading right here. And then we'll go to the combinational logic chapter, and let's get a little bit of background in terms of how to use Verilog, and then we're going to take that background and put it to work in constructing a half adder. So we'll start with just the basic Verilog introduction. Verilog is composed of a bunch of black boxes. They're called modules. They have inputs and they have outputs. So here we declare an input. It's a 8-bit array of switches. I call them SW to correspond to physical things on a demonstration board that I have. And we have some, unsurprisingly, LEDs. Those are outputs. And you always declare that. What does a module look like? It's a bunch of inputs and outputs. Inside the module, there's some contents. In this case, we're using an assign statement. An assign statement does what the name implies. It just takes the value of the switches and connects it directly to the LEDs. Now, one really important concept here is that Verilog is all about describing hardware. This may look like a program to you, right? There's some module declaration and there's some assignment statements and an end module declaration. So sure, you might call it a programming language, but more importantly, it's a hardware description language. So everything we do here, you must think of in the back of your mind how it physically translates to AND gates, OR gates, things like that. In our case, this assignment statement assigning the outputs, the LEDs, to the inputs, the switches, means we're just creating a wire, right? Our wonderful complex module is simply a wire. I'd like you to pause this video for a minute and go and spend a minute in this exercise. Go ahead and use what you've already learned about modules and just create a module with 4 bits of input, 4 bits of output. Eventually we'll talk about 4-bit adders, and just assign A equal to B. What you're able to do, of course, is type stuff right here. For example, obviously, we'd start by defining our module. The module name is Verilog Introduction EX1. And you can see how to do that looking at the previous exercise. Go ahead and define that module. click on Save and Run until you get a correct grade. You can see that it's going to give you a series of tests when your syntax is correct. In this case, we don't even have the basic syntax, but it'll give you a series of tests to let you know whether your program compiles correctly or not. All right, I'll talk with you after you finish that exercise. After you finish that exercise, let's go to the next page and talk about actually implementing a half adder. So to implement a half adder, as you know from that schematic, we've got an AND gate and an XOR gate. Let's talk about the different operators that Verilog offers for you to do things like that. Fortunately, most of the operators are very similar to the C language. Wikipedia's got a partial list. The system Verilog spec has a nice list. I'm going to go ahead and just open that in another tab so we can take a quick look at that. But essentially, we're going to use that assign statement that you just practiced in the last exercise, and you just apply an operator, right? Remember that everything in Verilog is a module, a black box with inputs and outputs. In this case, we've got a one-bit input of A, another one-bit input B, and a single bit of output C, something that's classic for just a standard two-input logic gate. So again, here's how you would create an AND gate. Let's go take a look at the gates that System Verilog also offers us. We're going to scroll down here to table 11-1 and you'll see lots of very familiar things. Verilog does offer an AND gate. Here's the OR operator. This is the XOR operator. And then it offers some less well-known things like XNOR and similar things. We can do bit shifts and a bunch of other stuff. It does support addition, subtraction, and even multiplication and exponentiation. We're going to get to those things in a little while, but to start with, we're going to actually hand code addition and subtraction so that you have a better and deeper understanding of how those operations come together. So again, go ahead and go to this next exercise. You can click on it here or simply click the next button and spend just a minute to go ahead and create that simple assign statement that would create C being the NOR, the not or of A and B. Don't forget, you'll have a function, they have some kind of operator here that goes in the middle, another input, and play around with that until you get the NOR operator done. Pause the video, finish that up, and now let's take, after you've done, go ahead and go to the next page, and finally we're ready to implement that single adder. Again, same sort of setup, but we have two inputs as before. We have B, of course, and A. Now we've got two outputs, our sum and our carry out. So you're just going to write two different assign statements. One is going to be assign carry out, and that's going to be some function of A and B. I'm just putting a question mark in there to represent it. And now you'll have a second sum to be some function of A and B. Again, don't forget your semicolon at the end, the assignment statement at the middle. Whenever you're ready, click that save and run button. Obviously, right now, this is a bunch of syntax errors because this is not a valid Verilog operator. So just remember, you're going to put an AND operator, an XOR operator. We've talked about those earlier, and you'll have implemented a half adder in Verilog.